Good morning, everyone. This is Jacob Palmer from Palmer Electrical. Welcome back to the Palmer Electrical YouTube channel. As always, if you like what you see in the video, leave a like, leave a comment, and tell me how you think I did, and hit the subscribe button if you feel compelled to do so. Today I'm taking you along with me on a new Tesla charger installation. Well, maybe it's not new. They're moving houses and they wanted me to disconnect their wall connector from one house and move it to the other one. I went there the other day to disconnect it. Let me show you a little bit about that. Get this pulled off from the wall. There we go. We'll give it a test. No boom. This morning I'm going to go reinstall it at their beautiful new home. I did a bunch of other work at this house also. A lot of lighting work, some new switches, recessed lights. The customer called it their forever home, so I wanted to make sure it was good for them. So I'm going to take you along on this installation, tell you a little bit about EV charging. We can talk about some code. And also I'm going to be trying out my new Flex 24 volt brushless drill. This is not a sponsor, no affiliation with Flex at all. This was a very generous gift from my friend Steve over at Steve's Woodshop and Tool Reviews. I installed a ceiling fan for him at his home earlier this week and we made a little video about it, and he gave this to me at the end of the video. So Steve, if you're watching, thank you. And if you're not Steve, you should go check out his channel. He makes really awesome tool review videos, and then he also has some woodworking content here and there. I'll link to his channel in the description. You should check him out. But without further ado, let's get started. I'm gonna hit the road and I'll catch back up with you at the customer's house. All right, customer's getting moved in, and here is our work area here. So here is our 200 amp main panel here. We've got 2 available breaker slots here. We're gonna relocate a couple of these lights and receptacle circuits up higher so that we can get our new 60 amp breaker down here closer to the main. It's not a specific requirement, but it's good practice to try to put your heavier loads down closer to the main breaker. And then our wall connector is gonna go right here below the panel, ready for charging. This receptacle here is installed in a cut-in box. This was added after the fact. So we're going to actually take this receptacle apart, and then we're going to use the hole that it made as access to get up into the bottom of the panel here and to route our wire down into our charger unit. I'm gonna start gathering up some tools and materials, and we're gonna get started. Got some 3/4 clamp connectors. Will fit right over this number 6 SE cable. This is number 6 copper SE cable. We'll talk about that here in just a minute. We're gonna get a couple of plastic bushings. Not strictly necessary since our conductors are less than a number 4, but it's just a little detail that I like to include. We got some other breakers here just to make some corrections inside this panel. When I was here for the quote, I found that there were some multi-wire circuits here improperly installed. They're supposed to be on a 2-pole breaker like this. Our charger unit and the backing plate. Screws and washers to mount it. And we'll go ahead and grab the trash bucket to have it handy. Let's crack open the panel so we can see a little bit better what we're working with. And there we are. You can see here we've got plenty of space to go out the bottom of this panel here. I'm thinking we'll relocate these 2 lights and receptacle circuits up here to the top part of the bus bar, and then we'll install our new breaker here. First, I'm going to get this taken apart so I can see what kind of access we have, how hard this is going to be. You can see here that this is the wire that went down for this pretty clearly. So we'll follow this up, and it goes right here to this one. Plug in our tester and make sure it's dead. Now this customer wants the full charging ampacity of this Tesla charger. Max rate of charging is 48 amps. Now we're installing it on a 60 amp circuit. That's because EV charging is considered a continuous load. Continuous loading in the code book is defined as 3 or more hours of constant power. And of course, charging a car, you're usually going to be charging for 3 hours or more. So what that means is we have to size our circuit at 125% the normal rated ampacity of the charger. Of course, we can do the math. 48 times 1.25 equals 60. They manufacture the chargers to charge at those specific rates on purpose because they know electricians have to size them a certain way. So for example, a 40 amp EV charging circuit only delivers 32 amps at 240 volts to the car. Same thing with a 50 amp plug-in style. Those chargers are limited to 40 amps. 40 times 1.25 equals 50. In our code book, that information is pretty easy to find. Of course, we're dealing with car chargers, so you can find that back in Article 625, which specifically deals with electric chargers. It's in the 2023 code book. It's titled Electric Vehicle Power Transfer System. It's titled that way because this article also covers things like whenever vehicles have the ability to backfeed into a home. There's also specific requirements for that are found in Article 625. They just grouped it all together. Of course, if you come right down here to 625.42 rating, the EVSE, electric vehicle supply equipment, shall have sufficient rating to supply the load served. Electric vehicle charging loads shall be considered to be continuous loads for the purposes of this article. We can also find the continuous loading requirement in Article 210. Article 210 just covers branch circuit requirements. Branch circuits not over 1,000 volts in the 2023 code. And then if we follow it down, we should find 210.20A right here. Continuous and non-continuous load, where a branch circuit supplies continuous loads or any combination of continuous, non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. Same thing in Article 215, continuous and non-continuous load plus 125%. So it's all over the code book, very common knowledge. I've got this receptacle taken apart here, and I can see that there's horizontal blocking going down right here below the panel. So we're gonna have to get drilled through that. That shouldn't be too much of an issue though. First thing I wanna do though is get all these wood shavings out of the panel. I trimmed a little section of the drywall out below, and we're going to use this knockout right here to feed our cable up into, this 3/4 inch knockout. I trimmed a little bit of this drywall here so I can get my screwdriver in to tighten the clamps on that clamp connector, and I can see where the paint ends here around the panel cover. This will be covered up whenever we're done, so it'll still have a nice clean finish. Use some needle nose to get in here and get this outer ring. There we are, got our knockout. I'm going to use some of these magnetic stud finders to identify where our stud is. This one here. That horizontal blocking is about 4 inches from the bottom of this receptacle hole here. You know, it's probably just a 2x4, so we'll add an extra 1.5 inches to it, 5.5. And then it looks like the bottom of that, it's going to be right about here. I'm just going to eyeball it for now. And then I'm going to take my level and mark a perfectly vertical line right in the middle of the stud there. You'll see what that's for here in just a moment. I'm gonna go ahead and get our wall plate prepped up, ready to install, and then that'll help me figure out how this needs to be drilled or if I need to cut some extra access here. So here's our wall plate. Before there used to be a conduit coming up the bottom here, so I'm gonna use one of these weatherproof knockout seals here up into the bottom. These have a foam gasket. That'll be nice and sealed up properly. Here we are. That way nobody can stick their fingers up in there. And we're going to come in this back left little knockout here. This is just a plastic ring knockout, so I'm actually just going to drill this out with a step bit instead of trying to knock this out because the plastic is liable to bend and break. And then we're going to mount it to the stud with the far right screw holes in the mounting bracket here. I'm going to get started doing that. This will be an awesome time to test out this new drill. Thanks again, Steve, if you're watching. Appreciate it. Of course, normally I'm a member of the red team, but I gotta say, this does feel pretty good in the hands, and the battery came fully charged out of the box. Got a step bit here. I never met my real bit. We're gonna go ahead and drill out this knockout here. This is Jacob, Palmer Electrical. Here's the thing, I've switched CRM software a couple times since I started Palmer Electrical, but I think Jobber's here to stay. Yeah, I can definitely help you out with that. It's always a hassle trying to switch systems, but I can honestly say Jobber had the lowest learning curve. I was booking jobs and sending quotes the day I started. So they just need a good phone number and a good email address. And for me anyways, the biggest time saver has been the scheduling tool. It's easy to use, it's easy to understand, and it gives you the option to schedule later if your hands are tied up, desktop or mobile. And then the service address? If you have a business or you're thinking of starting one, click the top link in the description. It gives you 14 days for free, as well as a special discount if you decide to sign up. Only available through this link. If you're interested, you should really give it a try. It's a powerful tool. Thank you, Jobber, for sponsoring this video. Thanks for your call and have a great day. There we go. Perfect. I think I'm gonna go ahead and line up these top holes with that horizontal brace so that we can get some extra screws so that this can be held on a little bit stronger. 4 inches down from this hole here, 3/4 to the middle of that 2x4, just lightly horizontally right here. So that's where our top holes of the Tesla charger will line up. So I'm gonna go ahead and mark where our clamp connector is gonna end up. This is an 1 3/4 hole saw here, big enough to fit the clamp connector inside the hole behind the Tesla charger so that it'll lay perfectly flush. I made a mark so I can see where it is, and we're gonna do this nice and slowly. Uh-oh. Looks like we might have to move this over. I drilled in there and I drilled directly into wood. When I drilled into the wall here with my hole saw, I could feel that I was drilling into wood with the pilot bit. So I wanted to stop and cut this access hole. I wasn't planning to have to do this, but I'm going to use one of these 2-gang low voltage rings and a 2-gang blank cover here to disguise this hole. I was hoping to avoid having to do that, but you gotta do what you gotta do. I'm feeling back here now, and it just feels like there's an extra stud sistered up against this one. So we're just gonna have to move this whole section over about 1.5 inches. I'll take a measurement here and just get around about 8 inches over. And yeah, this lines up pretty much exactly with where the hole is that I was gonna drill. The good news is that it's not a big deal because this is gonna get covered up with the Tesla charger. So we'll just move this over and drill here instead. That's what it's supposed to feel like. I got my hole drilled through this horizontal blocking. That's pretty much all the hard parts out of the way. All right, I'm gonna go ahead and start working with the wire now. Now this is number 6 SEU, and this is copper SEU. That's an important distinction. Number 6 Romex would not be acceptable for this application. That's because NMB wire, which is Romex, is only rated for 60-degree terminations and insulation. That's found back here in Article 334, non-metallic sheathed cable. And if we go down here to ampacity, the ampacity shall not exceed that of the 60-degree rated conductor. That means that if we go back here, if we come back here to Article 310, and then come to the ampacity table, this is table 310.16 here. You can see here, the 60-degree column right here, for number 6, it's only 55 degrees right there. Our SE cable that we're using, back here in Article 338, if we go to that same section, or shall not be subject to the conductor temperatures in excess of the temperature specified for the type of insulation involved. We can look on our cable here and see that we've got XHHW-2 insulation that's printed on the outside of the sheathing here. If we go back to table 310, 310.16, XHHW right here falls under the 75-degree C column. If we come down to number 6, we can see 65 amps under the copper section here. It's important that you use copper. It's not the same for aluminum. 50 amps if we've got aluminum with 75-degree insulation as well as 75-degree terminations. So that's why I think number 6, copper SE, is a great choice for EV charger installations like this. And it's also allowed to be concealed inside of a wall, so it makes the installation nice and simple. I'm going to feed my SE down the hole that I drilled here. And then we're just going to work it and into our hole for our clamp connector. Enough to make it to the terminals inside the charger. And feed it into our clamp connector. We're going to tighten down our connector just so it's snug. Don't over tighten these clamp connectors. It's possible to damage your wire. Screw and a washer. Looks nice and plumb to me. And I like to use these nice big fender washers on these Tesla wall plates. just because it's a plastic wall plate, and that washer distributes the pressure. And there we are, nice and secure. I'm gonna put some extra screws in here because there's nothing that says we can't. This is very solid on here now. I'm gonna go ahead and thread one of my bushings on that connector, and then this will be ready to trim out. First, I'm just gonna go ahead and get our cable the rest of the way up into the panel. I always like to make notes. Whenever I made this quote in Jobber, I made a note that the bottom of the panel here was open so I could feed it up through. I also made a Jobber note of where this receptacle was, that this had access. I took the cover plate off and saw it was a cut-in box. So I could make that part of my plan. Just helps make my job a little bit easier. Get snug. I'm gonna put a bushing on it. Okay. All right, there we are. So now you can probably see we've got our cable fed down through our hole. See it going over and up. I'm gonna get some fire caulk in the hole that we drilled through that horizontal blocking there, and then we just gotta button it up. We're just gonna have to use our fingers. I'm gonna dispense some just kind of on top of it. Ideally, this fire caulk is injected directly into the hole next to the wire. Since we're just working kind of through access holes here, that's not gonna be completely possible, but I'm getting it spread out around as best I can around that SE cable. I'll get my camera down in there and you can see. That's an important step for fire safety. A lot of people skip that. Do a tug test. All right, so there was originally at this outlet location a regular duplex. I'm going to put a GFCI receptacle here. 210.8 here talks about ground fault circuit interrupter protection, or GFCI. 210.8A is dwelling units, which we're in, and 210.8A2 specifically says garages. They're required in the garage, so we'll get this installed. Making sure we're hooking up to the line side of the GFCI. All right, I'm gonna do the panel work first, then we'll trim out the Tesla charger. All right, we got these two circuits relocated up here. I figured out that the dishwasher and disposal was on a multi-wire circuit, and they had them both on a single tandem breaker here. That is a big no-no. Not only because it's supposed to be on a 2-pole breaker, but with it being on a tandem breaker, both lines of that multi-wire circuit are being fed from the same phase, or at least the same side of the phase. And what that means is the neutral that those wires are serving is now susceptible to higher than 15 amps of current. I'll link to a video that explains exactly why. I'm not good at explaining it, but it's a big no-no to do that with a multi-wire circuit on a tandem breaker. So what I did was I installed the 2-pole 15 amp breaker for that multi-wire circuit, and then I used that tandem 15 amp breaker for those two 15 amp branch circuits that I relocated. So that made it nice and easy to change. Now we've got our 2-pole 60 amp square D QO circuit breaker that we will snap in right here. We will get started stripping our SE cable. I'm gonna put a fresh blade in my knife to cut this SE cable. Start in the middle and just drag it down. And then I like to run my knife horizontally, nice and carefully, around the base, very gently, very carefully. Just like so. See how clean that edge is there? I try not to cut this inner wrapping if I can avoid it, just because it makes such a big mess. Turns into a million little pieces. I'm in no rush today, so I'm just gonna unwrap it. Sometimes I get comments about some of my practices, things along the lines of, oh, that takes forever, that takes too much time. Why are you going so slowly? That's overkill. Somebody said the other day it turns a 1-hour job into a 2-hour job. And the thing is if you're doing this job right and you are really paying attention to the details, it should take longer than normal. I feel like it's a really bad idea to be in the time crunch mindset when you're doing electrical work. In this line of work, little details that get missed can be can create big problems for you in the future. So whenever I do my scheduling, I always make sure to give myself plenty of extra time. I don't slam pack myself every single day. I try to make it so that I know that I have time for my customers and that I can give them extra time if needed. Instead of a situation where when I run into a problem, I have to hurry up and find a quick solution or jimmy rig something up. I don't think that's a good practice. I'm gonna grab hold of these ground wires with my linemen's and twist them together. All right, got our ground wire all twisted up. I'm gonna fold this back and then feed it up into one of these screws on the ground neutral bar here. Some extra slots available. Get that tightened down. Now we've got our 2 line conductors. Now, let's wire up our charger. EV charging equipment is some of my favorite work to do. Not really because it's super profitable, but just because I think it's kind of cool, honestly. I just like doing it. EV charger installation is such a competitive space now that you really can't charge all that much for it. I'm not even very much of a big green thumb guy. That's not me. But I just think the engineering is super cool. I've already decided that once my personal vehicle is ready to go, then it's going to be replaced with a new Tesla. Well, maybe not new, probably a used Tesla, but you get the point. Okay, we'll route this up and over. 50 inch-pound torque value here. This is my Wira torque screwdriver here. There's the model info. Just gonna get it snugged with this one, and then we'll take this just till you hear the click. There we go. Feed over L2. Get that snugged down. And then the terminal. Snug it down. There we are, 50 inch-pounds. The inside of the Tesla chargers have a little zip tie loop for wire management. Trim it. Now we'll take the charger unit. The 3 tabs on the back of the charger here slot right into these 3 jaws. Slots right over. We'll drop in the retaining screws. 2 on the top, 2 on the bottom. Here we are. Let's get our breaker turned on. Green light means ready to charge. All right, got most of my tools put up. I'm gonna make sure the last of my crumbs are cleaned up here. We've got it all buttoned up here. You can see my new labels installed, got our Tesla charger good to go and ready for inspection. It's Saturday today and Monday's Labor Day, so inspection's gonna have to be on Tuesday. But she's ready for it, looking good. Before I leave, I'll have the customer pull his car up and plug it in and, you know, we'll test charge. I never like to leave and walk away without seeing the car charging, you know, just to verify it works. Big thanks again to Steve from Steve's Woodshop and Tool Reviews for my awesome new flex drill. Big thanks to the writers of the National Electrical Code too for helping me do my job. Big thanks to my channel sponsor, Jobber. Again, if you want to check out Jobber business software, it's the top link in the description. Give it a try, 14 days for free with my link. So make sure you click that. All you business owners, entrepreneurs, prospective entrepreneurs, it's worth a try. And maybe most importantly, thank you for watching today's video. It's always a pleasure making these videos. Like I said in the beginning, leave a comment and tell me what you thought. How do you think I did? How do you normally do these types of installations? I love hearing all your feedback and different techniques and materials, so you know, leave all that in the comments. I love to hear it. Thank you for watching, and make sure you tune in next time. This has been Jacob Palmer from Palmer Electrical. See you real soon.